And we saw that this was a very valuable lesson to have. So we really wanted to make sure we had this lesson as our last lesson. Some of the further lessons we also cut because they were weird or they were above grade level, and we really wanted to make sure that kids got their at grade level learning. So just like a kind of information on why we did that. All right, so let's go ahead and get started. The line graph below tracks the rain accumulation measured every half hour during a rainstorm that began at 2 o'clock p.m. and ended at 7 o'clock p.m. Use the information in the graph to answer questions that follow. So, like we talked about in our last lesson, you can see the main purpose of the lesson right at the bottom. And the purpose of this lesson is to plot data on line graphs and analyze trends. This analyzing trends is the biggest part of this lesson. And we think that this is super important because you see these kinds of graphs everywhere. You can ask your parents, your family members. They see these all the time. And it's really important to understand what they mean because sometimes people use these kind of graphs to make people believe something. And we want to make sure you have the ability to analyze these and get information for yourselves instead of having to believe what somebody else is trying to tell you. So, in this bar graph, bar graph. In this graph, we're looking at rainfall, and we're looking at this based on time. So, how much rainfall fell over a period of time. We noticed that they said that they measured every half hour. If you look here, you can see every half hour is 2 spaces in this x-axis. So I'm going to first label my x-axis and my y-axis. Those are always very important to remember. Next, I kind of want to figure out when these, what time is in between. Because if I look at the questions below, I know that I need to know what time each of these are. I don't really need to worry about these ones. I'm just going to draw it. I don't need to worry about these ones right here because, like they said, it's measured every half hour. And if you look at the fractions, remember when we're thinking about these, we're looking at 2 different number lines. So if you think about this as being a whole number and a whole number, so this is 2 o'clock, this is 3 o'clock. The whole number is 2, the whole number is 3. In between these whole numbers, we have 1, 2, 3, 4 spaces. So that half hour is right after that second space. So 1, 2, half hour. So that's that half hour. So these end up being like 2:15, 2:30, 2:45, 3 o'clock. We're only worried about these half hours. So I want to go ahead and label those. So this right here is 2:30. So 2 o'clock, 2:30, 3 o'clock, 3:30, 4 o'clock, 4:30, 5 o'clock, 5:30, 6 o'clock, 6:30, and then 7 o'clock. That way when it's asking me questions below, since I know I'm looking at that half hour, I've got that labeled and I don't have to worry about it. Now I notice it's also got whole numbers on the side, but if you look, there's a whole lot of fractions in between. And if I notice down below, it asks me questions. I previewed the questions before, but it asks me specific questions about the fractions, so I want to go ahead and figure that out. If you were in my math group or my class, and I know some of the other classes, we really talked about how you can find out with even just a few points what the rest of the points on a number line are. All you really need is this 1. This 1 and this 0 down here tell you all the information that you need. I want you to think about, try and remember, and I want you to try it out yourselves and see if you can figure out the rest of the fractions that go in here. Go ahead and pause the video and try and figure that out. Okay, So we look between the 0, which this right here is my 0, 0. We look right there. It wouldn't be 0 on this axis, but it would be 0 here. The reason it wouldn't be 0 here is because this is 2 o'clock, so this would technically be 1:45 on this. Sometimes with a lot of these bar graphs, you'll notice that they don't have that 0, 0, okay? We've been working a lot with 0, 0 right here, but sometimes they put this y-axis, they cut off wherever that x-axis was. So you have to be careful and know that this 0 only is for right here, okay? I know that we have 1, 2, 3, 4 spaces between this 0 and the 1. You could also see it between here. 1, 2, 3, 4 spaces. In fact, this is probably even more reliable since they didn't label that 0 below. And as we saw, it doesn't always start with 0 on here. So this right here between these two whole numbers, we see that there are 4 spaces. And there are 4 spaces here. So this is confirmed to be a 0. And each of these are fourths. So this is right here 1/4, 2/4, which is equal. Cancel. 2/4, which is equal to. Let me go ahead and change this to a smaller. Okay, so 2/4, which is equal to 1/2. And this would be at this line. This would be at this line. This would be 3/4. I was labeling the spaces, but 1 and 1/4, 1 and 1/2, 1 and 3/4, 2, 2 and 1/4, and then 2 and 1/2. Knowing your equivalent fractions, if they ask you something that has to do with an equivalent fraction, so if it says where is the 2 and 2/4, you should know that this right here is equal to 2 and 2/4. Okay. So now that we've got that labeled, that'll make it a little bit easier to answer these questions. How many inches of rain fell during this 5-hour period? You may be thinking that you have to add up all of these, but nope, since this is over time, it's asking how much at the end of the 5-hour period, which ended up being 2 and 1/4 inches, which if you wrote that in decimals, that would be 2 and 25 hundredths inches. Since this is a word problem, you want to write that in complete sentences, but I'm not going to take up your time by doing that here. During which half-hour period did 1/2 inch of rain fall? So what you're doing is you're looking between 2 points for this. And you're seeing which ones had 1/2 hour of rainfall. So I'm going to start at this first one, and I'm going to see that since it started at 0 amount of rainfall and it ended at 1/4 rainfall, it only grew 1/4. Another way to think about that, instead of adding each one, since we know each of these lines represent 1/4, how many lines does it have to grow to represent 1/2? It has to grow up 2 lines. So these 2 lines, so between here and here, that is 1/4 plus 1/4, which is equal to 2/4 or 1/2. So between these 2-hour period, this 30-minute period, 1/2 inch of rain fell. So it added that 1/2 inch to that 1/4. So that was between 2:30 and 3 o'clock. I want you to write these in complete sentences. You're not just writing what I have down here. The line went up 1/2 inch as time went on from 2:30 to 3 o'clock would be one way to say that. During which half-hour period did rain fall most rapidly? I can easily tell that because if it fell more rapidly, if I think about that word rapidly, that means it fell very quickly. It fell super fast. So between one of these half-hour periods, rain fell really fast. I want you to think about how you can tell by looking at this which half-hour period fell really fast, really rapidly. I can tell that right here it fell really fast because it got really steep. A lot of rain fell. It went from 1 inch of rain to 1 3/4 inches of rain, which would equal 3/4 of an inch of rain fell. You can also see by seeing how many spaces it went up. 1, 2, 3. 3 1/4 is 3/4. So that's between 4:30 and 5 o'clock. Whoops. 4:30 and 5 o'clock. So I would say something like rain fell most rapidly from 4:30 to 5 p.m. because the line is the steepest. That is where rain fell the most rapid. After that, it would be something like right here, where it was the next steepest line. Okay? Why do you think the line is horizontal between 3:30 and 4:30? So all the way between here, this line is steep. Why? I'm sorry, the line is not steep. It's straight. Why is that line straight? Well, it's straight because no rain fell. It started off at 1 inch and ended at 1 inch. So no rain fell during that time. So no rain fell from 3:30 to 4:30 p.m. For every inch of rain that fell here, a nearby community in the mountains received 1.5 feet of snow. So I'm going to highlight that. So for every inch, the mountains received 1.5 feet of snow. How many inches of snow fell in the mountain community between 5 p.m. and 7 p.m.? So, I look back up. Between 5 p.m. So 5 p.m. started at 2 inches? No. Started at 1 3/4 of an inch. And it grew 2 spaces. So it grew 1/2 inch. So if that grew 1/2 inch, so I would write a total of 1/2 inch of rain fell between 5 and 7 p.m. That means the mountain community got half. So if this is 1 inch, if 1 inch of rain fell and the other place received 1.5 feet, I would say half of 1.5 feet, which sounds weird, but if you think of how we multiply fractions, it's half of, remember that multiplication sign means of, half of 1.5 feet, writing that in a mixed number, 1.5 feet would be 3/2. Half of 1.5 feet equals 3/4 of a foot of snow. So a total of 1/2 inch of rain fell between 5 o'clock and 7 o'clock p.m. That means the mountain community got half of 1.5 feet of snow, or 3/4 of a foot, which is equal to 9 inches. You don't have to know that, but it's kind of a little fun fact.